Hello and welcome to part 8 of my Rust series. In this video, we will be covering dangling references and lifetimes. If you haven't watched my previous video about generics, then do check that out as well. So in this video, we will be taking a look at dangling reference first, and then learn about lifetimes, and then use those to ensure there is no dangling reference. So this is a very simple piece of code with two variables. The variable r is defined within the main block and has this lifetime, whereas variable x is defined within a smaller code block with smaller scope and has this lifetime. Within this smaller code block, we are borrowing the value of x within r and then printing it outside that smaller block. This means that while printing, we are trying to access the borrowed value of x, which does not exist anymore. Now it's quite easy to handle it in this situation, as we can just move the declaration of x above r and our issue is resolved. But in real world scenarios, it's not always this easy. Lifetime annotations don't change how long any of the references live. Rather, they describe the relationship of lifetimes of multiple references to each other without affecting the lifetimes. Now the compiler defines the lifetime internally, but if you want to explicitly define the lifetime, you can use an apostrophe followed by a lowercase letter. We generally use A for first lifetime annotation, then B, and so on. Now let's take a look at an example where the explicit annotation of lifetime can be useful. Okay, so first up we have a variable main var, which holds a string slice. Now we are passing this on to a function which will process it and then return a slice. Within the function, we have two variables, test var and find var. The test var is another slice similar to that of main var, whereas the find var is a smaller slice. If this find var slice exists in main var, then we return the main var, otherwise we return the test var. But this logic is within a different function which is test2. Now at the return type of this test2 function, we have an error which is missing lifetime specifier. And that's simply because there are two lifetimes that can be returned. One is the main var and the other one is the test var. The compiler doesn't know which lifetime it will be returning, so to prevent a dangling reference, it's asking us for a explicit lifetime. Assigning lifetime in a function is very similar to that of generics. After the name of the function, we put angle brackets and within that we give the explicit lifetime. Now, the only two parameters that need this lifetime are the ones that we are returning. Since the find var variable is only for logical processing and not for returning, its lifetime is not needed. Now, even though all the errors are gone, you might still be confused that why is this okay? Because according to the logic within test2, the variable that will be returned to the res variable in main will be the test var, and its lifetime ends with the test function. So how is this valid? These string slice variable are global variables, and their values are stored within the compiled files of the function. Now this is because of the static lifetime. If we had something else like a vector, then this would not have worked. So let's replace the string slice with a vector and see what we can do in that case. Now this is the same example, but I have replaced the string slice with a vector. And since this vector is not static, it's giving me an error in test function. Cannot return a value referencing a local variable. Now the easiest solution to this problem will be to make this vector static, which is pretty straightforward. Instead of using the let keyword to declare the variable, we'll use the static keyword. The only thing is we can't use the vec macro while declaring the static integer vector. We'll make this variable mutable and then we'll push values onto this. Now we can't directly push values as it is unsafe, so we'll first create an unsafe block. Now this variable is still mutable, so if we pass its reference, the reference is also mutable, which means the test2 call should also be within the unsafe block. Now since structures can have parameters that hold a reference type, we can also define lifetimes for them. And suppose you want to add a generic parameter to a structure that already has a lifetime, then we can simply put a comma after the lifetime and then use the uppercase letter to define the generic type as well. Now this covers most of the stuff related to the lifetimes, but there are still few things that you can learn on your own. Especially the 3 rules that the compiler used to figure out lifetimes. It's not necessary for a beginner to learn this to work with lifetimes, but this will give you a better understanding of how the compiler works and help you understand more about the lifetimes in general. You will find a link to the original docs within the description. So that's all for this video. Please give a thumbs up if this video was useful. Do consider subscribing and I will see you in the next one.